All right, so 5.3, and we finally get to the meat of the chapter, which is logarithmic functions and graphs. So a logarithmic function is, get this, the inverse, 5.1, of an exponential function, 5.2. So what we're going to look at first is how would you find the formula for the inverse of an exponential function y equals 2 to the x? Well, the first thing you would do is recognize that f of x is y, so you could replace the f of x with a y, and then you'd switch the x and the y. So you'd end up with x is equal to 2 to the y. And as we know, with every function, we like to express it as y equals. But in this case, how the heck would you isolate y? The y is in an exponent, so the opposite of 2 to the y would be taking the yth root of both sides, but then you're stuck with a y root, which isn't solving for y. So instead, we're going to use a sentence. We're going to say, okay, well, y is the power to which we raise 2 to get x, right? So x is 2 to the y, so y is the power that you're raising 2 to get that value of x. And we'd say the inverse, like f to the negative 1 of x, so the inverse function is the power to which we raise 2 to get x. But that's awkward. We would never say that. So instead, mathematicians have defined a new symbol. We would say that y equals log base 2 of x. So it says is read the logarithm base 2 of x. I never say the whole word logarithm. So I would just say log base 2 of x. So that's how this is read. And what it means is 2 is the base, y is the exponent that you're raising 2 to get x, or simply, this is the power to which we raise 2 to get x. Whew, fun. Now, just like everything, we have a square root function, which when we write a square root, we don't put the 2 inside. We have an exponent of 1, we don't write it up top. Well, logarithms are kind of the same. So there's a common logarithm, which is a log base 10, and we write it without the base. And then there's the natural logarithm, so that using that Euler or Euler's number, however you want to pronounce it, that we used as a base in our exponential functions, it can also be the base of a logarithmic function. And instead of just dropping the e, we call it a natural logarithm, so we write it as ln. So this is the natural logarithm. So the first thing we're going to do is just practice reading and understanding what a logarithm means. So, how would you read this one? Okay, y equals log x. Well, if you were to read this, you could read it as y is log of x, right? Or you could say y is log base 10, which is hidden, of x. Just like this one could be read as y equals the natural logarithm of x, or y is log base e. Wow, that's some horrible writing there. Base e of x. So the key thing is the log of x, right? And then it'll be log base 10, log base 2, log base e. It could be log base anything, but you're taking the log of x with some base. What does it mean though? Well, this is going to take a little bit of that, understanding this sentence thing. So we're going to practice with these up here, and then we're going to just have this formula that allows us to go from logarithmic to exponential form and exponential to logarithmic form. So when I look at this one, again, this is y equals log base 10 of x. What this means is the power that we're raising 10 to get x. So this is your base, and the answer is the exponent that you're putting on that base to get the thing that you're taking the log of. Okay, so with this one, this would mean e to what exponent would give you x, or it's the exponent that you're raising e to get x. And this is actually converting from what we call logarithmic form to exponential form. And then we also like to be able to go from exponential to logarithmic. So let's just practice this. So I've got 4 questions here, and we're going to do what we just did. We're going to go from logarithmic form to exponential form. And for me, the easiest way to do it is to remember that your base stays your base. So this is a base t. T to the exponent x, because this is the thing that we're solving for, is the exponent that you're raising the base to, will give you m. Now that one's nonsensical because it's all letters, okay? But the next one, this is a true statement. Log base 2 of a 32nd is negative 5. What does that mean? Well, it means that 2 to the exponent negative 5 is 1/32, right? So 2 to the negative 5 would be 1 over 2 to the 5. 2 to the 5 is 32, okay? What about this one? Okay, so for this one, you have to remember that there's a base 10 that is not written because mathematicians are lazy. So this is saying that 10 to the exponent 2 is 100. 2 is the exponent that you're raising 10 to get 100. And then last one here that we're going to practice, this is that natural logarithm. So understanding that if you want to write it in exponential form, you have to first write it as log base e of 5. And then to write this in exponential form, you would say that e to the exponent 7 is 5. So again, I always just remember that the base stays the base. And then it would be way too easy if you just went, oh, let's scrap the log. 10 to the 100 equals 2. No, you have to go kind of cross and backwards. So you go 10 to the 2 equals 100, right? Or e to the 7 is equal to 5. Awesome. Okay, so the next video is going to be super short, but I just want you to go and practice converting from logarithmic form to exponential form.